Question 3 starts off with integration by parts. So we're given this equation and we're told to use integration by parts or otherwise. So we can rearrange it to get dv equals t squared sine 2t dt. If you do the integral on both sides, we can get that v equals the integral of t squared sine 2t dt. And we're going to use integration by parts to do this. The integral of dv is just v, obviously, and then we're not going to worry about the constant because we still have to do this integral, so there's no point. So we're going to I'm not going to do the DI method, which I did last year for it, because I think it's better to use the method that's actually on the course, so you can get the partial marks. We're going to let u equals t squared, because it's algebra and the inlate rule, or liate. And as well as that, if we differentiate t squared, it'll be 2t, then 2, then 0, and we want it to go to 0. But if we differentiate sine 2t, it just keeps repeating, which isn't very helpful. So that's why another reason of thinking of it. So then we can say that our dv is sine 2t dt. Again, if you're wondering why we're doing this, that's so we can sub into this formula so that we have a u and we have a dv, and then we can calculate the answer by subbing in. So in our here we have a v and we also have a du, so we need to get those. So we can get du by taking the derivative of u to be 2t, which means that du is just going to be 2t dt. And then to get v, we can integrate both sides. We get that v is the integral of sine 2t dt. We have to make a substitution here. I'm not going to do the substitution for all of them though, because it's the exact same, but I'll do it for this one. So to find the integral of sine 2t dt, one way is to just remember that you have to divide by the derivative of the inside. The derivative of the inside is 2, so you get minus a half sine cos 2t. Sorry, we get minus a half cos 2t plus c, of course, if that was it. But in case you're not able to remember that, or you don't want to remember that, we can use substitution, because we see that we have a linear function on the inside. So we don't know how to do sine of 2t, but we can do sine t. So we let u equals to 2t. That means that du dt is 2, which means that dt equals du over 2. So this gives us the integral of sine u. And this u, by the way, is different to this u. I'm just showing you how to do the substitution to solve just this integral. Sine u, and then instead of dt, we're going to replace the dt with du over 2. That's equal to, we can write a half times the integral of sine u du, which is equal to, the integral of sine is negative cosine, so we'll have minus a half cosine u, which is equal to minus a half cos of 2t, because u is equal to 2t. So that's where I'm getting this from. But I think in leaving cert maths, you have to learn anyway that if you have a linear function inside sine, you have to divide by the derivative. So we get minus a half cos of 2t as our answer there. So now that we have all of it, we can sub into our formula. So this integral, the integral of u dv, u being this and dv being this, that's this. So our answer v will be equal to, so it's u times v, so it's going to be t squared, and then v is equal to minus a half cos 2t. So times minus a half cos 2t. We get minus the integral of v. V is minus a half cos 2t. So minus a half cos 2t times du. And du is 2t times 2t dt. Now it's important that you don't multiply this 2t by this 2t, because this 2t is inside of the cos, and this 2t is being multiplied. So let's do a bit of cleanup. So v will be equal to minus t squared over 2 cos 2t. Then minus and a minus makes a plus, and I'm going to take the constant. Actually, we don't have to. So we'll get plus the integral 2 divided by 2 multiplied by 2. They'll cancel. I'm going to bring the t first just to avoid confusion. T cos of 2t dt. Now we have to use integration by parts on this again to get rid of it. So we'll let u equals to t, and we'll let that dv equals to cos 2t dt again. So we'll get that du dt equals 1, or in other words, du is dt. Again, why are we getting du? So that we can sub into this formula. There's a du there. And then as well as that, we also need a v. So we need to get a v out of here. We can do that by integrating both sides. We'll get that v is equal to, and then the integral of cos 2t. So it's going to be sine of 2t, and then divided by the derivative of the inside because of the substitution that I made up there. Same reason. We'll get a half sine 2t as our v. Now we can sub into the formula. So v equals minus t squared over 2 cos 2t. That hasn't changed. this, what we did right here, that's replacing this part here. That's replacing this integral. So we'll have plus, and then instead of this integral, we are going to have whatever we get from this. So it's going to be uv. So we'll have t times, and then v is sine 2t, and then that's all over 2, minus the integral, and it says of v times du. So v is a half sine 2t, so I'll just move this over. So we'll have a half sine 2t multiplied by, and then multiplied by du, and du is just the same as dt. So times dt. And now you can see we finally have an integral that we can just do. So I'm just not going to bother writing the rest, but the rest is still there. I'm going to take the half out the front to avoid confusion. Because it's a constant multiple, it doesn't change the integral. So we'll have sine 2t dt. And then the integral of sine 2t dt, well, the integral of sine is going to be negative cosine. So it'll be a half times minus cos 2t. And then again, dividing by the derivative of the inside, we get over 2 again. And then finally, since we're done with integrating, we're going to add our plus c at the end. And so all this stuff is still here as well. So I'll write it out fully one more time. V is minus t squared over 2 cos of 2t plus t over 2 sine of 2t. And then we have minus, and a minus makes a plus. Well, half times a half is a quarter. So plus a quarter cos 2t plus c. Okay. Now we need to figure out what c is. They tell us that v is equal to 0 when t is equal to 0. Okay. So we can replace v, when v equals 0, t is 0, and we know that's true. So that's going to be 0 equals this whole thing, we're multiplying by 0, that's going to be 0, plus this whole thing we're multiplying by 0, that's going to be 0, plus a quarter cos of 0 plus c. Cos of 0 is equal to 1. So that means that we get 0 equals 1 times a quarter is a quarter plus c. That means that c is equal to minus a quarter. So that means that our equation for v, which I'm going to copy down because I'm lazy, is going to be, instead of plus c, we're going to have minus a quarter. Minus a quarter. And now, finally, we're asked to calculate v when t is pi over 2. So we want v of pi over 2. That's going to equal 2. So we're going to have minus pi over 2 squared over 2 cos, and then pi over 2 times 2 is just pi, plus, and then we're going to have pi over 2 is pi over 4. We'll have sine of pi plus a quarter cos of pi minus a quarter. And if you put that into your calculator, making sure that your calculator is in radian mode, when you put that into your calculator, you should get an answer of 0.7337, and this is velocity, so that's in meters per second as our unit. And that's the answer. Part B then is a pretty nice collisions question. So there's two identical spheres, each moving with a speed of u obliquely. They both make the same angle with the y-axis, and there's a coefficient of restitution. We need to calculate in terms of e and u, and I think a little mistake they made, and alpha, because they didn't, there's no way to solve for alpha here, and as well as that, they asked for an answer in part 2 in terms of alpha, so it should be in terms of alpha as well. The velocity of each sphere after the collision. So first thing I always do is I do a little chart. So I have before, I have after, and then we have A and we have B. So beforehand, we have our little triangle with velocity here, and then our angle alpha is here. So of course this can be u cos alpha as our j velocity, and u sine alpha as our u cos alpha as our I, and u sine alpha as our j. For A, because it's moving to the top right, they're both positive. So we'll have u cos alpha I plus u sine alpha j. For B, it's moving to the left, so we're going to have minus u cos alpha I, because minus is to the left, but it's still going up, so it's plus u sine alpha j. And then afterwards, well, we're trying to find the velocity afterwards. So for our velocity of A, it's just going to be, we'll just call it VA in the I direction. And then, as you know, the J direction stays the same because the I axis connects the centers of the spheres. And then for B, I'll call the final velocity of B VB plus U sine alpha J. You might be saying, why isn't one of these negative? Well, I like to just keep them both positive, because then at the very end, if one of them is negative, it would say VB equals, for example, minus 3, and then we'd have minus 3i here. Perfect. You can put this as minus VB if you want. The only difference is at the end, you get that VB equals 3, in which case we'd still have minus 3i. So it's the exact same either way. I just like to keep them as positive because then the sign will make sense. Then if I get minus as my answer, I know, oh, it's going the other way. That's how I like to do it. So as always, we have two facts: conservation of momentum. We're doing this in the I direction. And since they both have the same mass, they're both identical spheres, we don't have to worry about it. So it's going to be, I'll write the whole thing out though, MUA plus MUB equals MVA plus MVB. But because the masses are all the same, we just have UA. So the initial velocity of A is U minus U, because the initial velocity of B, or sorry, this is in the I direction. So it's actually going to be U cos alpha minus U cos alpha, because this is the velocity of A in the I direction, and then plus this velocity, so they actually cancel. That'll be equal to VA plus VB, which means that VA will be equal to minus VB, because this is equal to 0, bring one to the other side, and we get this fact. And this should make sense. The velocities, because they're both identical and they have the same speed, the velocities after are the same, they're just going in opposite directions. Next up is Newton's experimental law, which states that the relative velocities equals the coefficient of restitution. So again, this is just in the I direction. So VA minus VB, we don't know those, we're trying to find those, over, then UA is just U, minus, and then UB, or sorry, it's U cos alpha, I keep forgetting that, because we're talking about the I direction, minus, and then we have minus U cos alpha again for B, because they're going in opposite directions. That'll be equal to minus E. That means that VA minus VB, so we have U cos alpha plus U cos alpha, that's 2U cos alpha, which means that we can bring that up here, equals, so we'll have minus E minus 2, because there's two of them, EU cos alpha, as I had here. We know that VB is equal to, or this minus VB is the same as a VA, so VA plus VA equals that. That means that 2VA equals minus 2EU cos alpha, which means that VA equals minus EU cos alpha, which again should make sense, because then VB is just the minus of whatever VA is. That means that VB equals positive EU cos alpha. And again, this should make sense because they're moving in opposite directions and they have the exact same conditions. When they hit off each other, they're going to move in the opposite direction. So A before was moving to the right, this is positive, and afterwards it was moving negative to the left. And that's why if I made this a minus VA and I took that into account already, the answer I would have gotten here would have been positive EU, and then I might think, oh, but that's going to the right. I might forget that I put the negative here. So that's why I like to keep them as positive so that I get the sign in my final answer. Anyways, it says the velocity of each sphere. Velocity is a vector, so this isn't good enough. So for A, the final velocity will be, so we said the velocity after is VAI plus U sine, I didn't write alpha there, U sine alpha j. So we'll have VAI, so that's going to be minus EU cos alpha I, minus EU, so the velocity vector for A will be equal to minus EU cos alpha I plus U sine alpha j. And for B, it's going to be equal to, the velocity will be EU cos alpha I plus U sine alpha j. And that's our answer for the velocities of both spheres. Again, important that it's velocity, that it's in a vector form. Part 2 is a nice application of the dot product. So it says A and A move perpendicularly after the collision. Show that E equals tan alpha. So perpendicularly, whenever you see perpendicular, the first thing that should come to your head is the dot product, which says that if we have vectors, we'll call them A dot B, that's equal to the x components multiplied together plus the y components multiplied together. And we know that when it's equal to 0, that means they're going to be perpendicular. So we need to multiply the x components, add them to the y components. That'll give us the dot product. And because they're perpendicular, we know the dot product equals 0. So we'll have that minus EU cos alpha multiplied by EU cos alpha plus And then we have, these are both the exact same, so I'm just going to write, it's going to be u squared sine squared alpha equals 0. Let's bring the e's to the other side, so that'll be minus e squared u squared cos squared alpha. So we'll have that u squared sine squared alpha equals e squared u squared cos squared alpha. We can cancel the u squareds, and we get that sine squared alpha equals e squared cos squared alpha divided by cos squared sine squared alpha over cos squared alpha equals e squared square root everything. We'll get that e equals sine alpha over cos alpha, and sine over cos is always equal to tan alpha as required.